SimCenter 3D can help automakers achieve quieter, smoother vehicles using simulation for noise, vibration, and harshness, otherwise referred to as NVH. In this demonstration, the concern is about noise generated by an air intake manifold. Such manifolds come in all sizes and shapes and are a key component for engines to make sure air is flowing smoothly into the combustion chambers. The components are not actually stressed, but they generate very high interior noise from the engine that causes the manifold to vibrate and radiate noise. SimCenter 3D is an ideal tool to study and improve acoustic performance of manifolds and improve the car's end customer experience. SimCenter 3D makes geometry editing for CAE easy. In this model, you first need to simplify the geometry and remove some holes that have no bearing on the acoustic simulation. This is simply and quickly achieved using direct editing through Siemens synchronous technology, where geometric features can be removed with no knowledge of how the part was built, nor is any specific CAD expertise required. Next, because you're performing an acoustic analysis, it's necessary to generate the interior and exterior acoustic enclosures for this manifold. What would otherwise be a time-consuming task is completed in minutes thanks to the powerful geometry engine that is core to SimCenter 3D. To create the interior air domain, you proceed by extracting a copy of the part and select the interfaces to delete. Because the faces are tangent continuous, they're all selected, but by quickly selecting the opposite surfaces, SimCenter 3D knows to remove the outer surfaces and generate the internal cavity. Similarly, an exterior volume can be created by generating a simple volume from which you will subtract the manifold and a newly generated internal volume. Now that the acoustic volumes have been generated, you can create the corresponding meshes. Here again, one of the unique capabilities of SimCenter 3D is a unified and integrated environment where you can immediately mesh the components. First you mesh the manifold, then you mesh the acoustic volumes. Again, a powerful capability with SimCenter 3D is the ability to create multidisciplinary models where you can have a structural mesh and an acoustic mesh generated at the same time. NX-Nastran as the acoustic solver can automatically work with otherwise incompatible meshes. Because we have selected a vibroacoustic solution, SimCenter 3D intelligently provides the right element types. For example, note that you can select an acoustic fluid type tetrahedral mesh for the acoustic bodies. Lastly, you need to define a mesh that will represent the microphone surface above the manifold. Once these meshes are defined, they can be assigned their material properties and you can add the loads and boundary conditions. You now define a vibroacoustic simulation, and it should be noted that the pre- and post-processor interface is the same user interface whether you're doing a structural, acoustic, vibroacoustic, or even a thermal analysis. This ensures a consistent user interface. It makes it easy to efficiently run solutions for modes, vibration response, or acoustic response analyses. In this simulation, you want to evaluate the acoustic performance of this air intake manifold. In doing so, you need to define some forcing frequencies from 100 to 1000 Hz. And to speed acoustic solution time even more, SimCenter 3D has the ability to define an automatically matched layer, or AML. The AML is similar to a perfectly matched layer, or PML, that is used for acoustic simulation. However, you don't need to physically model the AML unlike you do for a PML used in other tools. This means the AML, which is only available in SimCenter 3D, reduces both your modeling time